Hello, everyone. Um, yeah. My name is Desen. I'm the Elizabeth Georgeson Research Fellow in Data and Digitalization for Net Zero, and that's exactly what I will be talking to you about today. So we've been asking ourselves this question for a while now. How can we decarbonize energy systems, and how can we do this before 2050? And here you can see a time series where we can see what our electricity generation is made up of. What you'll realize here, and I took this from a random day in March this year, majority of the demand was actually covered by natural gas, and even in some cases, coal had to come in and help. There was also some input from wind as well, but I want to highlight here that this is not the complete picture. Now we have more and more distributed generation on the consumer side, and we also have more flexibility from smart assets such as EVs that's not being captured here. This brings me to my next slide. While decarbonizing the energy grid, we have been decentralizing and digitizing it. So we have been installing more and more rooftop solar panels. We're now buying more EVs, and we're installing electric heat pumps and so on. This means we have millions of assets on the consumer side, but the problem is that all of these assets are invisible to the operator. And we need data from these assets to achieve decarbonization on time through optimization and automation. And this is exactly what my research looks at. This is also backed up by a statement from Energy Data Task Force that says data is crucial for building a smart system that achieves these objectives on time. This task force was commissioned by Innovate UK, BASE and Ofgem, and they estimated around £40 billion of savings by 2050 if energy data is used effectively. They also highlight a talent gap in data, energy, and engineering, which is what I'm aspiring to fill. So now I will present you 3 examples from my project portfolio. The first one is looking at energy systems in 2032. Here I built a digital twin with my industrial partners, you can see at the top, specifically looking at 3 different neighborhoods in Aberdeenshire. And if we could keep the same infrastructure without any upgrades till 2032, with up to 45% penetration from EVs and heat pumps, and increased penetration from solar PV and batteries and so on. Using optimization and also local energy training techniques, we were able to keep the system stable and also obey user needs and comfort. The outcomes from this project were accelerated decarbonization and up to 10 to 15% savings for end users annually. We also found a trade-off between these 2 outcomes through carbon-aware local energy trading. The major impact from this project included for it to be used in a pilot project in real life, and also that it contributed towards a commercial software product owned by Scene Connect. The second project I want to talk about is on smart contracting. So if you're new to the concept, don't worry. It starts with an agreement between the parties, like a regular contract. And then we establish the smart contract, which is made up of text, but also code. And then the third step here is what makes it smart. So the smart contract is able to check if a criteria is reached through communication with other digital devices, and then in the end, execute the value transfer. So to give an example here, imagine you came home, you plugged in your EV, and within half an hour of you plugging in, your system operator said, hey, everybody else also plugged in, and the grid is now under stress. Can you pause charging for the next 15 minutes? And in return for this, we'll give you X amount of pounds. And if you actually, they offered you this and also to your neighbors. And smart contract is able to track who has actually done the action and reward people accordingly. So it's able to communicate with your smart meter, but also your EV charger to validate whether you pause charging for those 15 minutes. So what I want to highlight here is that smart contracting can help us deal with the increasing volume of energy data we have on the system and help us automate actions like this. One of the major outcomes of this project was that that we published the first open source code in this area that you can find on GitHub. And we also published a comprehensive review about how smart contracts can be used in energy. So if you're wondering where else we can use smart contracting, you can have a look at this paper, but here is also a summary for you. We distilled 180 papers and also 13 industry projects into 11 emergent application areas. So these range from automated demand-side response services, like the example I gave, but also smart contracts can help us enable new market designs like peer-to-peer trading. On the other hand, it can also give us more granular control over the system, so things like smart charging of EVs, battery management, but also auditing and certification of carbon footprint or supply chain. This brings me to the third project that I'm going to talk about today, third and last, which is on net zero heating and cooling. So as you may know, around 80% of UK homes use natural gas for heating. We know that we will move away from this either through electrification of heating, using heat pumps and similar, or through hydrogen or a hybrid path. But the problem is that there is no universal solution that fits all. So on this project, I have been simulating different types of houses that you can see there, but also different types of households, so different socioeconomic backgrounds and different levels of closeness to feel poverty. And what this project is trying to achieve is justice in energy transition to help us inform a more just policy for the future. And for this, we have been doing multi-vector models, which means we're not only modeling electricity systems, but also heat and transport in addition. I think there is some kind of timing. And we've also been outputting open source optimization and decision-making tools to help policymakers. So to summarize, my research team encompasses data and energy and anything in between. And the type of research tools and skills that I can offer are in these 5 key areas. First one being optimization and AI, similar to the scheduling I've shown you in the first project example. Second one is on decentralized energy technologies, including smart contracts. Third one is multi-vector energy networks, like the one I've shown in Dispatch. Fourth is on digital twins. So digital twins can help us visualize what is happening in the network today, or in the systems today, but also how it will look like in 2032, 2050, and beyond. Oh no, sorry. Lastly, the last point I want to mention is energy markets. So energy markets are key for us to do efficient allocation of supply to demand. This also goes for energy. And there are different kinds of energy markets, which include flexibility markets, but also peer-to-peer and other niche local energy systems. This brings me to my last slide. Here I just want to summarize 3 different points that I foresee as challenges in the energy space. The first one is the hidden cost of decarbonization. Sorry, I'm not touching it. Hidden cost of decarbonization. So when proposing solutions such as smart contracting or any data-driven model, we have to be careful about its carbon footprint as well. So here I included some scary infographics to make that point. So as you can see, dark data, so i.e. unused data, can actually emit up to 6 million tons of CO2. And there is also a lesson to be learned about decentralized technologies from fintech. For instance, we all know that Bitcoin has a big carbon footprint. In this case, they're estimating to be the same as the energy consumption of the Netherlands. But actually, data centers worldwide consume double that. So we have to be aware of these. The second point is that we want people to share data, and we want to optimize everything as engineers. But not everybody wants to share that rightfully. They don't want to upload their data to big servers. So we need to find ways to make this system more cyber secure, and also find ways to incentivize people to share data. Lastly, in the UK right now, we have around 33 million vehicles. Imagine if all of those were EVs. So how do we solve that optimization problem, and how do we automate that information flow? So I hope today I highlighted some opportunities along the entire energy value chain that would benefit from both data and digitalization. That's me. Thank you.